Hi everybody, exercise 1.1, main question number 4, solution for sub question number 11. Okay. Now from 10th question, if you observe 10th sub question and 11th sub question, it almost looks similar, but no. Why? Here the power is going on increasing. There the coefficient was increasing. Let us see what difference it makes. Though it looks similar, the answer are different. Let us see now. So we have a square, a cube and a4, a raised to 4. We will call them as a1, a2, a3 and a4. Now, first we try to find out the common difference. a2 minus a1, which is equal to, a2 is a square, a1 is a. So, a square minus a, which is equal to, common a is taken outside, we get a minus 1. We cannot further simplify, we won't be getting a constant number because the terms are all variables. So, the difference also stays as a variable. Now, let us try to find out the common difference between the next two consecutive terms. That is a3 minus a2, which is a cube minus a square. Here you can see the common terms in both of them. A square is common. So, I take a square out and I get a minus 1. There is no need of further continuing the problem because here this both can be equal only under two cases, when a is either 0 or a is 1. These both will become 0. But in general context when we speak, these both are not equal. So we say therefore there is no common difference. There is no common difference. If common difference is not there, then automatically it is not an arithmetic progression. So we can say therefore not an. There is no continuation for this problem further because they told if it is an AP, then find out the next four terms. That will be A5, A6, A7 and A8. We cannot find out anything here because it is not an AP. Number 12, main question number 4. Now, here you find roots. We are dealing with surds right now. Directly when you look at, these are called as pure surds. These are pure surds because there is coefficient, their coefficient is always 1. If coefficient is not equal to 1, we call them as mixed surds. Right now, we will have to convert these pure surds into mixed surds. Only then you can compare whether they are like or unlike. See, if they are like surds, for example, root 2, 2 root 2, 3 root 2, 4 root 2, 5 root 2, these are all like surds. Other examples like 1 root 5, 10 root 5, 15 root 5 or x root 5. Now they are all like surds because the irrational part has to be same. Whereas if you say root 2, root 3, they are called unlike surds. You cannot add or you cannot subtract them. To find out common difference, we need to have like surds. So to convert this into mixed fraction will be the first step to identify whether they are like surds or not. Now, root 2 remains root 2. Root 8 can be written as 4 2's root of 4 into 2. See, 8 can be written as a product of two numbers. One of them has to be perfect square. So here I have 4 as a perfect square. Next, root 18. 18 can be written as its factors, that is 9 2's. Because 9 is a perfect square, I will be writing that first. Next, I have root 32, which also can be written as a product of a perfect square and another number, that is 16 2's. You may ask me, so why it has to be written like this? Why can't I write as 8 4's? 8 4's are 32. Can't we write like that? Yes, of course. 4 is a perfect square there. But next step of simplification, root 2. 4 root 2, 4's root, you know the answer of root 4. Root 4 is nothing but 2. What about this remaining 2? That I cannot find out the root of 2 because it is an irrational number. It remains as it is. Please observe here carefully. Root of 4 is 2. I write it as 2. But root of 2, I cannot change it into anything else. It remains as root 2. If you similarly apply the same logic for the next number, root of 9 is 3, root of 2 remains root of 2. And root of 16, for example, root of 16 is 4. So, this is 4 into root 2. Now you observe, these are all now mixed surds because their coefficient is not 1, but Look at the irrational part, root 2, root 2, root 2, root 2. Now they can be simplified. Okay. So you can compare this with variables like this is x. Consider in your mind that this is x. Then this is 2x, 3x, 4x. Now they can be simplified. Let us try to find out the difference between the consecutive terms. First, a2 minus a1. Our a2 has become now 2 root 2. So 2 root 2 minus a1. Our a1 is root 2. So root 2. Remember what I told you? They have to be simplified similar to variables like 2x minus 1x will be 1x. Similarly, 2 root 2 minus root 2. I generally tend to take examples of some eatables. Example, it's like 2 apples minus 1 apple. What happens? 1 apple. So, this is equal to root 2. That is the difference. Now, let us try the same for the next two consecutive numbers. That is a3 minus a2. a3 minus a2. a3 is 3 root 2. So, 3 root 2, as I told you, you can assume as 3 apples minus a2 is 2 root 2. So, 2 root 2, you can think of 2 apples. 3 apples minus 2 apples, 1 apple. Similarly, here it becomes root 2. We should be happy that we got the same answer, but not completely, because one more set of consecutive terms you have to check. Let us check for that. a4 minus a3, which is equal to 4 root 2 minus 3 root 2, which is equal to, again, 4 minus 3 is 1. So, it is again root 2. So, now we should be very sure that there is common difference, right? Therefore, the common difference, what is the common difference? Root 2. Root 2 is a common difference. If this is a common difference, is it an AP or not? Yes, it is an AP. So, you can say therefore, this implies, sorry, so what do you understand from this? Therefore, given terms are in AP. Given terms are in AP. Given terms are in AP. If they are in AP, the question continues. What? You have to find out the next 4 terms. Let us try to find out the next 4 terms. So let us find out the next 4 terms. The next term is A5. Since we already have A4, we want A5 as the next term. How will you get A5? According to the definition, add the common difference to the previous term. So, previous term is A4 plus common difference. What is A4? That is root 32, but you know after simplification it is nothing but 4 root 2. The simplified form, remember? Yeah. If you don't remember, kindly go back in the video and please check. It is 4 root 2. So, I will write it as 4 root 2 plus D. What is D? D is root 2. So, D is root 2. What will happen now? 4 apples plus 1 apples. That's how I asked you to assume. Okay. So, 4x plus 1x. That is 5x. Like that. 4 root 2 plus root 2 is 5 root 2. So, you got the 5th term. Let us try to find out the 6th term. What is 6th term? A5 plus D, which is equal to 5 root 2 plus root 2, which is equal to 6 root 2. So, next one is A7, which is A6 plus D, which is equal to 6 root 2 plus root 2, which is equal to 7 root 2. Very similarly, the last one, it's easy, I suppose. You can solve even before I solve, please. So, that is A7 plus D, which is equal to 7 root 2 plus root 2. That is equal to 8 root 2. So, you can write just at the end, you can add a sentence saying, therefore, the next 4 terms are, what are the next 4 terms? 5 root 2, 6 root 2, 7 root 2 and 8 root 2. Good. To sub question number 13. Let us have a look at the solution. Here we have root 3, root 6, root 9 and root 12. Let us call them A1, A2, A3 and A4. I am trying to convert them into simpler forms. I have simplified the SHAJU'S. Root 3 cannot be simplified further. Root 6, however, can be simplified. See, I have applied this law here. Root of xy, inside a root whenever you have xy, we can write it as root x into root y. We can write them separately as a product. See, root of a product can be written as product of a root. See, here we have square root of xy. I am writing the square roots for both of them separately. Here the product is inside the roots. Here it is a product of the roots separately. So applying that idea here, you can have a look. I have applied that idea for each one of them. So root 2 into 3 becomes root 2 into root 3. Root of 3 into 3 becomes root 3 into root 3. Root of 4 into 3 becomes root 2 into root 3. Root of 4, that is, root of 4 I have written the direct value as 2. Now you may ask me, sir, why can't we write root minus 3 directly? Of course you can. I just wrote this so that I can take out the common elements whenever I do subtraction or addition. That's all. Now have a look at this. First we go for a2 minus a1, which is root 2 into root 3 minus root 3. Common is root 3. So root 3 is common in both. What is left out is root 2 minus 1. So this is the first difference I get. Let me try to find out the difference between the next two terms, that is a3 minus a2. a3 minus a2 is equal to, see, root 3 into root 3, or you can simplify this as 3, no problem, minus root 2 into root 3. Now what is common in both? Root 3 is common. I take out one root 3 common outside. What is left out? If I take out root 3 common outside, root 3 minus root 2. So I got root 3 minus root 2. Both the differences are not same. See, root 3 is same, root 2 minus root 1 and root 3 minus root 2. If you try to find out the values of root 2 and root 3, approximate values of both, and then subtract them, you will find that these two are not same. They are not one and the same. So what can you say? We will say common difference does not exist. So there is no common difference. There is no common difference. If there is no common difference, then what will you say about the AP? Sorry, then it is not an AP. So you just can mention that this is not an AP. So you don't have to find out the next 4 terms. The problem stops here. Sub question number 14. The numbers are 1 square, 3 square, 5 square and 7 square. Now, let us call it A1, A2, A3, A4. Similar to the previous problems. Let us continue. Now we got to find out A2 minus A1, right? So first A2 minus A1, that is 3 square minus 1 square or 1. Values, 3 square is 9 minus 1, which is equal to 8. Let's try to find out the next difference between next two consecutive terms, that is A3 minus A2, which is equal to A3 is 5 square minus 3 square, which is equal to 5 square is 25, 3 square is 9, 25 minus 9, which is 16. There is no need of going further as we have got two different numbers and therefore there is no constant number that difference we are getting. So there is no common difference. We can say this implies there is no common difference. So what can you say therefore? The given terms are not in AP. You can say they are not in AP. They are not in AP. If they are not in AP, what can you say then? You don't have to find out the next 4 terms. The question, the solution ends here. Sub question number 15, the last question of the exercise goes as follows. 1 square, 5 square, 7 square, 73. Let's name them as A1, A2, A3, A4 and continue the very similar method what we have used for all the remaining problems. Now, first is A2 minus A1. So, A2 minus A1, that is equal to 5 square minus 1 square, which is equal to 25 minus 1, which is equal to 24. Visible again? Akkade barta ide 24. Ayyo, alla barta ide. Okay, cut ಮಾಡ್ತಾ ಇದ್ದೀನಿ. The next a3 minus a2. a3 minus a2, which is equal to 7 square minus 5 square, which is equal to 49 minus 25. 9 minus 5, 4. 4 minus 2, 2. So again 24. Good. We have so far got common difference. Let us test for one more pair of consecutive terms. If it is yes, then we can conclude that yes, this is an AP. If not, we can say this is not an AP. So last is 73. That's A4 value minus A3 value, which is 7 square, equal to 73 minus 49. 3 minus 9, no, 1 carried. 13 minus 9 is 4. 6 minus 6 remains. 6 minus 4 is 2, 24. 73 minus 49 is also 24. So finally now we can say that there is a common difference. So we can say this implies the common difference is equal to 24. Good. We have got the common difference. Now what can you say about this given sequence? We can say therefore given terms are in AP. Therefore given terms are in AP. Okay, good. So if they are in AP, they have asked you to continue the process and find out the next 4 terms. So next 4 terms. Pause. So the next 4 terms are A5, A6, A7, A8. Let us start with A5. By the definition, it is previous term plus the fixed number or the common difference. So what is A for? 73 plus D. What is D? 24. Add 24. 73 plus 24 is equal to 3 plus 4 is 7. 7 plus 2 is 9. 97. That is our A5. Let's go for A6. A6 is A5 plus D, which is equal to 97 plus 24. 7 plus 4 is 11. 1 carry. 9 plus 1, 10 plus 2, 12. 121. Which can also be written as 11 square, because we know that 121 is 11 square. Next comes A7, which is A6 plus D. What is A6? Either you can write 121 or 11 square. Both are same. I'll write 121. Makes my work easy. 121 plus, sorry, I forgot the brackets. Always use the brackets while substituting values. Please don't forget. 121 plus 24, which is equal to 145, which is not a perfect square, so we keep it as it is. We won't be able to write it in terms of square of a number. It's not a perfect square. A8 is equal to A7 plus D, which is equal to 145 plus 24, which is equal to 5 plus 4 is 9. 4 plus 2 is 6. 1 is on 169, which is nothing but 13 square. You can either write 169 or 13 square. Both are right. So finally we can just add one sentence. It will be nice to finish it in that way. The next 4 terms of the AP are 97, 11 square, 145, 13 square. Or you can just write the numbers in the box. Thank you.